Did you know that a tropical cyclone, a hurricane, and a typhoon are all the same things, just in different areas of the world? I'm Teacher Jess. Welcome back to Geo Cafe. And in this video of favorite finals, we are going to take a look at the questions that you need to be able to answer about tropical cyclones. So I have been pouring through past papers to see what are the favorite questions on tropical cyclones, and I put them together with their memo answers to help you study for your exams. Now, please just remember that these questions may be frequently asked, but it does not guarantee that these questions will be in an exam or that this is the only way that they can be examined. There is no guarantee what topics will be included in different exam papers and how they may be asked. Okay, let's check it out. So the first thing we need to do is just become a little bit more familiar with tropical cyclone. Okay, tropical cyclones are also known as hurricanes or typhoons. They don't often ask this, they won't often ask about the different names, but they might use a case study of a hurricane or a case study of a typhoon, and then they expect you to know that they are referring to a tropical cyclone. The only reason why they have different names is because they occur in different parts of the world. The first question. This is probably the most frequently asked questions, and if it's not this one, it's a slight variation of this one, which is question number 2. But what are the conditions necessary for a tropical cyclone to form? First and foremost, we need warm ocean waters. So warm ocean waters is anything above, let's say, 26 or 27 degrees Celsius. Okay, and with that, we have this very humid air. And this humid air, it contributes to being an unstable air. We have a lot of latent heat as a result of the condensation of this humid air. And all of that is fuel for the tropical cyclone. We also have to see Coriolis force. Coriolis force isn't really detected, or it's not detected over the equator. So we only find tropical cyclones just away from the equator. So about 5 degrees north or 5 degrees south to about 30-ish degrees north or south. So within the tropics, but not on the equator. We need very light wind or almost no wind altogether, and some type of rising air or a low pressure system. And we typically find that along with a very steep pressure gradient. So where you have a strong low pressure, you have a steep pressure gradient, and that contributes to the formation of the wind, and then Coriolis force causes the deflection, and then we get a cyclone. And of course, on top of all of this, we need very little friction because it doesn't have energy to overcome this friction. The other thing that they like to ask is maybe not what is needed for the formation of a cyclone, but rather why did the tropical cyclone form there, or why did it intensify? So they might give you something like this, and then you would have to look out for where the tropical cyclone or the hurricane is located. So over here we can see it's over the ocean, we can see it's near the equator or on the tropics, so we can see this warm water, very humid, all of those things. That contributes to the formation of a tropical cyclone. You might have a little fact file that will tell you a little bit about the cyclone or about the condition or the season beforehand. But like I said, a tropical cyclone needs very warm conditions. So it is worth noting if it's the end of the summer season, or maybe it was an unusually warm summer, then you can expect a tropical cyclone to form or for it to be more intense than usual. It will be located over warm water. This warm water usually, like I said, between 5 and 30 degrees north and south. It will be over the ocean because that is the fuel that the tropical cyclone needs. It needs that water and that condensation. You need to have a Coriolis effect. You need very little or light wind, a lot of moisture, high humidity, so high evaporation rates, and if it re-intensifies, so if we find that the tropical cyclone was dying or losing its momentum or losing its energy, they might ask, why did it re-intensify? And usually that is because it moved back over water or back over warm water. So take a look at those little details. Okay, and then they could ask the opposite. Why did this tropical cyclone weaken or dissipate? So again, they could give you a map or a path that shows you where the cyclone went, and then you have to take a look at why did it start to dissipate at this point? Why did it become weaker? So over here we can see the red, that's when it was a very intense cyclone. And as it reached Madagascar, it switched to a yellow. So we can see SS, I think that's severe storm or something, and then it starts to die down after that. So then the question would be, why did it weaken? Why did it lose its energy? And usually it's because it met land. So because it encountered the friction of land, or because you could say it loses that energy supply of the warm water. So tropical cyclones need that constant condensation, that latent heat that is released when you condense warm water. And without that fuel, without that warm, moist air, it doesn't have the energy to keep going. So it loses its source of energy. It is off of any source of water. And it could even be that it's moved to an area of colder air. So even if it is still over the ocean, maybe it is colder water, and then it doesn't have that same latent heat and that same energy anymore. It could also just be that it's moved towards a high pressure system. Remember, we need low pressure, we need rising air for the cyclone to keep moving. And you can kind of see this moving away from the equator. So this hurricane over here, there it started on the 23rd of October, and there it moved north to the 30th of October. And this would mean that it's moving away from this warm water over here towards colder water over there, and that would cause it to weaken. So you can see it goes from like a black color to a gray. That would probably be losing that heat and losing that energy. And then it turns white over there where it hits the land, and then it encounters that friction and is cut off of its water supply. So then it dissipates. The next thing that they like to ask is for you to draw a cross section of a tropical cyclone. When drawing the cross section, make sure you include an eye in the storm. So you have to have a gap between the clouds, that is the eye, and also a very clear eye wall. So the eye wall, this is the towering part of the clouds on either side of the eye. And also make sure that you label the air movement correctly. Even though you might have some, or you do have very slight sinking air in the middle of the eye, the main movement of the air is rising in the eye wall. So if we look at it over here, you can see it a bit more clearly. We have this rising air inside the eye wall. You can see they didn't even include it in the eye anymore. But you can clearly see where the eye is, where the eye wall is, and how the air is circulating through it. The other thing they might look for is the rain bands. So the rain bands are these very clear strips of cloud where we have extreme rainfall. There you can see it as well, there and there. Also look carefully at how they phrased the question and if you need to include the weather that is experienced. So in this case, they have the strong wind, they have the symbol for thunderstorms, they included the type of cloud, that's the cumulonimbus cloud, they have heavy rain, they have gale force winds. So all of the different types of weather phenomena that occur with a tropical cyclone. Then when does a tropical cyclone occur? So a tropical cyclone will occur when the water is the warmest. And the ocean water is the warmest either at the end of summer or the start of autumn. So this is when the water, the ocean has had a full season to warm up, has this constant supply of sunshine, and it gets warmer. So right at the end of summer and before it starts to cool off in autumn, that is when we have our tropical cyclones or our hurricane. The specific months actually depend on the hemisphere. If it is the southern hemisphere, we experience them in the first half of the year, so that's February to April. And then if it's in the northern hemisphere, they experience it in the second half of the year, that is June to November. Okay, and then in which direction does the wind move? They might expect you to identify if it's in the northern or southern, or they might tell you that. That does make a big difference because in the southern hemisphere, it will move in a clockwise direction, and in the northern, it will move in an anti-clockwise direction. They could even ask you to identify which hemisphere a cyclone is in based on the way the wind is moving. In this case, they asked what direction is the wind blowing through Panama City. So if you can't already see from the context of this image, this is in the northern hemisphere. They did give a little bit more information to show where this was, but this is in the northern hemisphere, and there's Panama City, and they asked which way is the wind blowing. What they're expecting the students to be able to say or recognize is that this is moving in an anti-clockwise direction. So you can kind of also see it with the rain bands over there, that it's spiraling in towards the middle. What that means is that the wind will be blowing from the east to the west. So that means that it will be an easterly wind. They'll maybe say they'll be fine with like slightly northeasterly or southeasterly, as long as you can identify that it's moving from the east, and that's because it's moving in an anti-clockwise direction. Then, what weather is associated with tropical cyclones? So, the weather in general with tropical cyclones and hurricanes is incredibly destructive. The most prominent feature is the rainfall, the torrential and continuous rainfall that often results in other disasters like mudslides and floods and all of those things. We also have storm surges, which we're going to look at in a minute, gale force winds, which in themselves can take down trees, tear off roofs, destroy buildings, purely destructive by themselves. We may have thunderstorms, you would experience some type of low pressure, and in some cases, even tornadoes. If they ask about the weather conditions in the eye, they are looking to make sure that you know that it's actually the opposite that's true in the eye of the cyclone. So the eye of the cyclone or the hurricane will have the lowest pressure. It's the middle of the cyclone. Here you would have very clear skies, cloudless conditions. It'll probably be a little bit cooler. You might have some subsiding air, but basically just very calm, no real wind, cloudless and sunny skies in general. In some cases, people have actually made the mistake of thinking that when they're in the eye of the storm, that the storm has actually passed over, but they're only halfway through. What is storm surge? So I told you this is one of the things that happens, one of the conditions that the tropical cyclone brings in. And a storm surge is this massive rise of seawater along the coastline. So it's not like just a wave or a tide or anything like that. It's a abnormal rise in sea level that brings massive flooding, and it's driven by this wind that blows on shore. So if you think about how the tropical cyclone is spiraling around with all of the wind, it can pile up the water onto one side, and that water, this pile of waves coming into the coastline, would bring the storm surge. You might even notice, because of the low atmospheric pressure, that there's something of like a suctioning effect, and it almost pulls the water a little bit above and onto the shore. So here you can see what we mean. So this is your normal high versus low tide. And then with the storm surge and the constant waves, it really brings those sea levels up and it floods the coastline. Provide evidence that this weather feature is a tropical cyclone. It is worth being able to identify it, especially if they're comparing it to a mid-latitude cyclone. So maybe they want to make sure that you know the difference between the two and that you can pinpoint which one is which. So if these are all of our satellite images that we might get, the easiest thing to look for is the eye. So if you look right in the middle of all of these features, there is the eye of the hurricane or the eye of the tropical cyclone. In this case, they gave them a synoptic weather map, so they couldn't show the eye in the same way, but they drew that little symbol over there, that little spirally, almost blade looking symbol. First and foremost, look for an eye. A clear, well developed eye will tell you that this is a mature tropical cyclone. Then you would look for any types of circular bands of cumulonimbus clouds or rain bands. You're looking for the clockwise movement of air. If it's in the northern hemisphere, it would be anti-clockwise, of course, so just the cyclonic movement of air. They noted that you would have a very steep pressure gradient and close isobars, also that you would have a very low pressure, but it's worth knowing that this you can only see if it's on a synoptic weather map. So this one over here. These lines around it, those are the isobars. You can see that the isobars are really close together, so that tells me that this is a steep pressure gradient, but we wouldn't be able to see that on the satellite image. We wouldn't be able to say isobars are close together on this one because they're not depicted. And then, of course, I mentioned the obvious tropical cyclone symbol. That's this spiraling symbol over here. Any type of well-developed large vortex, that's what we're seeing over here, this clear developed vortex spiraling around. And then check to see what side of the continent the cyclone is on. So they would especially ask this if they want to make sure you know the difference between a tropical cyclone and a mid-latitude cyclone. Tropical cyclones will typically form on the eastern side of a continent. So over here we can see it, that's Madagascar over here and Africa there. And here you can see that the tropical cyclone is to the east of Africa. If it was a mid-latitude cyclone, it would be coming from the west and moving towards Africa from the west. Okay, and then the somewhat more obvious features, check to see if it's named. So check to see if the storm has been named yet, or if the name even includes tropical cyclone or hurricane. So in many cases, it will actually be in the name. Over here, we have a name and it says tropical cyclone. That is perfectly acceptable evidence that this is a tropical cyclone. And then finally, also take a look at the date. So make sure that the weather phenomenon that you're looking at does occur in late summer or early autumn. Again, this is worth keeping an eye on if you're comparing it to a mid-latitude cyclone. In South Africa, we have our mid-latitude cyclones in winter. So if you're looking at a map of South Africa and you see a mid-latitude cyclone or a cold front that's about to hit South Africa, or you know that it's winter, then it's not likely that you are also seeing a tropical cyclone. Then we are predicting the path of the tropical cyclone. So in this case, they want to make sure that you can follow the pattern the cyclone is following. Typically, tropical cyclones will move from east to west, but they will be deflected if they hit a landmass or if they're trying to stay over the ocean. So if you remember that the warm water is the fuel, it's what keeps the cyclone going. If it hits land or if it moves inland, it will lose that energy. So we often see the cyclone deflecting away from the coastline or deflecting north to try and prevent itself from moving further inland where it will weaken. But you also need to just track where it's already moving. So just follow the path, follow the trajectory. That is the most likely projection. I did see in one exam paper that actually asked students to draw the predicted path. So this was given, this is where the cyclone was with the date and the information. And then that part, that's what they asked the students to draw in. So they asked them to predict where the cyclone, or it was the hurricane, Yes, where the hurricane would be moving in the future, and that would obviously be based on its current path. And you can see over here, it's deflecting away from the coastline as if to stay over the ocean where it has water. How many tropical cyclones already occurred in a season? Hopefully, you know that cyclones, tropical cyclones, and hurricanes are named after an alphabetical order. They're also named in alternating male and female names. So if they ask you how many hurricanes occurred before Patricia, then you would have to count how many letters are there, A, B, C, D, all the way to Patricia, how many letters were before P. And then you would note that there were 15 storms before Hurricane Patricia. Same thing with Tropical Cyclone Freddy. So you would again count A, B, C, D, and then you would see that there are 5 letters, so 5 storms before F. So there were 5 storms before Tropical Cyclone Freddy. Now, the reason why I wanted to make a note of the male and female alternating names is that they might ask a student to predict what they think the next name should be. They're just checking to make sure you know how the alphabetical naming system works and that you also come up with a name that is opposite to the one, or male versus female, to the one that was already identified. So if we take a look at Freddy, Freddy, presuming is a male name. So Freddy being a male name. I'm trying to think of a girl's name with G, maybe Gabriella or something like that. So something starting with a G that is also a girl's name or a female name. How can tropical cyclones impact people? They love to ask about the impact of tropical cyclones, but it's worth also being able to identify how it impacts people in different ways. So people, economy, environment, and each of those. So let's just start with people. Many people might lose their homes, their possessions, their house, their anything. They might be forced to evacuate and they don't know what they will have to come back to, if there's even anything to come back to. So many people, they lose access to basic needs like food, water, shelter, and they'll be seeking out any type of help that can provide these things. There's obviously damage to property. There can be telephone lines down, cut off from communication, which means that you might not know what happens to family, where people are, what the latest news is. Is it going to get worse? Has the storm passed, etc.? You are likely to see flooding in low-lying areas, and this isn't just exclusive to coastal areas. Because of the excessive rainfall, you can also have flooding near rivers. So if a river floods or the river banks burst, it means that you can have flooding of homes along the rivers as well. So any type of low-lying areas would be vulnerable to flooding. And then, ironically, water cut off. Just because a place is flooded does not mean that that water is safe to use or consume. Very often, that water is contaminated because of the damage to sewage pipes or any other type of debris and pollution or anything else that's being washed into the water. So people don't necessarily have safe access to sanitation or clean water. And with that, of course, we can also talk about loss of lives. So people can be injured, people can be lost. And this isn't just from the immediate dangers of the storm, but also the secondary impacts of things like contaminated water or shortage of food. We can talk about the disruption of transportation. So if there's any type of damage to the infrastructure, people might not be able to evacuate, or they might not be able to access the important basic services. And one of these basic services is school. I know that there will probably be many kids that would be happy to be able to skip school for a few days. Interruption of regular school can be so disruptive to the long term, making sure that students can still complete their normal school year, maybe having students matriculate as per normal, or just any type of standard of living and support that schools may be providing. Then we take a look at the economic impacts of tropical cyclones. So naturally, there's a lot of damage that comes with these events, with these natural disasters, and this damage, especially in urban areas, can be very costly, especially to rebuild. We tend to see a lot of development along coastal areas, which means that there's a lot that can be destroyed and a lot that needs to be replaced. We might see destruction to communication, which means any type of interruption to businesses or economy, any type of slowdown in productivity, or even just the more literal people lose their businesses. Then, on top of the whole destruction of infrastructure, we also have to look at things like power supply. If you don't have electricity, then businesses don't necessarily operate. A lot of industries, or if not most, depend on electricity or having power in some way or another. We can also look at your more primary sector like farming. If we have excessive flooding, we could lose farmland, we could lose crop, and not just the immediate damage to crop or agriculture, but also the more long term. Let's say if there's a lot of salt water in the soil, then you wouldn't be able to replant. You might lose the ability to farm over that area. So there's also the long term loss of crop, and with that, income and food and everything else. In the same breath with agriculture, we can look at loss of livestock and equipment damage as well, which again will cost a lot to replace. And of course, there's then the delay of getting back to work and then the money lost whilst replacing, but also not working. So many people can lose their jobs either because they have lost their place of work or because their place of work can't necessarily afford them or afford to keep them in their employment whilst they're trying to get their business back on track again. So this is all looking at the immediate area that is being hit by the tropical cyclone, but we also need to bear in mind the distribution of goods and services from a place. So if we have disruption of transport, we might have people not being able to get to work or not being able to deliver things or not being able to communicate with a business that is located in that place, that even though they are not there, that they needed to communicate with. And generally, people don't like to visit places that have just been destroyed by a tropical cyclone, so you would probably also see a decline in tourism. And that is a big form of income for a lot of places. Then finally, we're looking at the environmental impacts. So environmental impact can be anything from flash flooding, landslides, soil erosion, all of the above, especially when many of those things can have a secondary impact on the economy and on the people. The flooding obviously makes sense with excessive rainfall and we have all of this water washing over the land, but that can cause saturation of the soil, which can trigger mass movement. So that's its own type of disaster that can happen. For example, a landslide. We can have loss of crop, of course. We can maybe lose the soil, the topsoil, if we have excessive soil erosion, and then maybe deposition of silt where we don't want it, like maybe dams or water channels or anywhere else. We can look at the collapsed trees, the destruction of the ecosystems, habitats, loss of biodiversity, and all of those elements. And then, of course, there are a few more disasters that can happen as on top of the hurricane, which would be something like a tornado or riptides. What can actually be done to try and reduce these impacts? What precautions can be taken either by the people or by the government to try and make this somewhat less impactful? Of course, we can't necessarily stop a hurricane or a tropical cyclone, but we can just reduce its impacts. Okay, so let's start with by people. So one, people can move to a safer area. This could be higher ground or just away from the coastline. It's very easy to say evacuate the area, but in some cases where we have islands, there's nowhere else for people to go. Then the best thing they can do is to move to higher land where they're not on the coastline or not on low-lying areas that might get flooded. They can pack some important supplies like warm clothes, water, food, your emergency supplies like lights or medicine or first aid kits, and all of those things that we tend to forget. But we must be careful not to overpack. People must avoid packing too many things and only take the essentials. Then, of course, there is seeking assistance, staying informed, staying up to date, in tune with the radio or the TV or social media, wherever else people can get their information from and updates, and follow the advice that is given to them. They must make sure they're familiar with their evacuation routes and the safety protocols, and possibly evacuate early to try and avoid traffic delays. Obviously, as everyone tries to evacuate at the same time, there will be this massive rush and everyone is then delayed. Where people can't evacuate, they can try and secure their homes. So strap down anything that might be loose, add weight to things that could fly off, possibly board up windows, put down sandbags to try and block water from flooding in, or anything else like that. Then, what the government can do. First and foremost, to try and avoid the problems or the destruction, is to not build on these low-lying or these coastal areas. And if they do, try to restrict the type of building. So maybe make it something that is easier to rebuild if it is destroyed, like maybe parks or recreational areas. And then use strong, sturdy building structures and material. So things that can actually resist these storms. Then invest in research, in tracking the cyclones, in studying how they formed using satellite imagery or remote sensing to predict when they might occur or where they might move to next. And that way we could warn the people and provide them with all the appropriate information. Make sure that we have somewhat other good communication system with the people, and provide assistance to anyone who's in a very vulnerable situation. For example, your elderly. Have a good evacuation system set up, and then make sure everyone knows what the evacuation procedures are. Then more physical things could be building flood barriers and, of course, providing emergency shelter and provision for the people. And then the last of the questions was, how do tropical cyclones impact MEDCs and LEDCs differently? So let's start by going into MEDCs first. So MEDCs, your more economically developed countries, tend to have more money available to prepare them for these tropical cyclones. So they're better prepared beforehand, and they're able to address it better afterwards as well. So they have more funds available, more money, more research, more resources and information. So they have better warning systems, they have better monitoring systems, satellite imagery, they can communicate with people, they maybe have better social media setup or news setup or radios or anything like that. They might have better evacuation systems planned. Maybe more people are informed or at least up to date because of these communication systems, and people are able to respond quickly to the emergencies. People tend to have more backup supplies like generators or batteries or anything like that in case stuff runs out, so they are somewhat more prepared. And people and businesses and all of those also usually have insurance just in case something goes wrong, they can get back on their feet. And on top of that, there's less likely to be damage with the better infrastructure and the stronger buildings. Unfortunately, LEDCs can't say the same thing. So our less economically developed countries, they don't necessarily have good infrastructure. They have quite poorly built houses. They don't necessarily have the right warning systems. So it's very easy for these types of infrastructure to get destroyed. And maybe it wasn't even working properly to begin with. We can have poor communication, not maybe having all of the technology, and maybe not everyone has access to that technology for information, especially if we're thinking about social media and cell phones or any type of device to communicate. It might not be as easily accessible for everyone in LEDC. Then poor evacuation procedures, or maybe people just don't know what the appropriate evacuation procedures are. They might lack any types of reserves for emergency supplies like food or water. And on top of that, many of these countries already have food insecurities. So as soon as a disaster hits, there isn't necessarily a backup because maybe there wasn't enough to begin with. Many of the people and the companies and anyone involved might not have the necessary insurance for a disaster situation or any kind of spare funds. So if a disaster hits people, one, they're not prepared, and two, they don't necessarily have the money to get back up again. Especially since so many people in LEDCs are subsistence farmers. So they're just growing produce to support themselves and to feed their families. So if a disaster comes along, like a flood or massive soil erosion, they are losing all opportunity to provide food for themselves or for their families. And they don't necessarily have extra cash lying around to just go buy some food now. We can also look at the lack of medical care. That also speaks to maybe the poor infrastructure and any type of waterborne diseases. Maybe we have sewage systems that break down. Maybe we don't have enough hospitals or emergency services to get everyone to where they need to be. And then, of course, there is just the impact on the economy, which means that it's even more slowed down. So, not only is the economy not developing, but it's held back even further. It first needs to repair itself before it can develop again or continue to develop. And very often LEDCs are reliant on other countries for help. So where MEDCs might have the emergency funds and the emergency stacks of food or water or medicine they can immediately provide to the people, LEDCs are waiting for other countries to provide them with that. And with that delay, we have more lives lost and more people left in danger. So I hope that this was helpful. And of course, I do just want to give credit to Slides Go. That is where I found the template for these slides. It was wonderful not to actually have to make all of this myself, so it's very useful. I hope that this video was helpful and that you maybe had a few questions answered. If you have a particular topic, a particular section that you would like me to go over as you prepare for your matric exams, let me know. I'll happily revise that section. Otherwise, I hope you have a lovely day further, and I will see you again next time. Cheers! Bye!